Okay, so in this lesson we're going to take a look at the derivatives of some other trigonometric functions. We talked about sine and cosine in the last lesson, so in this lesson we're going to look at the tangent, the cotangent, the secant, and the cosecant function, and we're going to learn the derivative rules for those four functions. And of course we want to use these rules in combination with our other derivative rules like the chain rule and our logarithmic derivative rules, etc., etc. And eventually we're going to be using these things to solve problems. So from the last lesson, what we learned was that if we had sine x and we wanted to do the derivative, we ended up with cos x. And if we started with cos x and we did the derivative, we ended up with negative sine x. Okay? So we want to extend this to the reciprocal trig functions and our tangent. Now, I've listed these relationships here because what you see is that these other four trig functions that we're talking about today, tan x, cotangent x, cosecant x, and secant x, can all be expressed in terms of sine and cos. So it is possible, if you don't remember the derivative rules for cotangent, let's say, you can always derive it by expressing your cotangent function in terms of sine and cos, and then going from there. So we can derive expressions for these derivatives for all of these things by expressing them in terms of sine and cos. So just to show you how that's done, let's figure out what the derivative rule would be for the tan function, assuming we didn't want to just look it up somewhere. So let's take tan x and think of it as sine x over cos x. If I wanted to the derivative of sine x over cos x, well, I would use the quotient rule. So the derivative of tan x is going to be, let's see, if we apply the quotient rule to sine x over cos x, the derivative of sine is cos x. So we'll multiply that by the denominator, cos x, and then we'll subtract our numerator, sine x, times the derivative of the denominator, which is, derivative of cosine is negative sine x. And all of this is divided by our denominator squared. So that's a pretty ugly expression. Can we make this a little bit simpler? Well, let's see. Cos x times cos x is cos squared x. Sine x times sine x is sine squared x. So we have cos squared x plus sine squared x all over cos squared x. We can simplify this even a little bit more if we remember one of our trig identities from advanced functions, particularly up in the numerator. Sine squared plus cos squared is equal to, Jennifer, 1. So this simplifies to 1 over cos x squared. Okay. And if we wanted to simplify this even further, we can go back up here and say, okay, 1 over cos x is secant x, so 1 over cos squared x is secant squared x. Okay, and that would be sort of our final expression here. Okay. So what we're going to find here is that these four derivative rules that we're looking at, they kind of follow a bit of a pattern. Okay, we've looked at the first one here. The derivative of tan x is secant squared x. The derivative of cotangent, well, let's see, if the derivative of tangent is secant squared, the derivative of cotangent is cosecant squared x. seems a little bit appropriate. But there's one thing we were missing. This has a negative sign on it. Anytime your original function starts with the letter c, the derivative is going to be negative. I'm not exactly sure why, it just is. So derivative of cosine is a negative sign. Derivative of cotangent is negative cosecant. The two other ones we have to learn are the derivative of secant and the derivative of cosecant. Well, the derivative of secant is tan x secant x, okay? So when we did the derivative of tan x, we ended up with secant. Tan and secant always go together. So when we're doing derivative of secant, it's tan times secant. And notice that these four that we're looking at always have sort of two trig functions multiplied together, okay? So if derivative of secant is tan times secant, the derivative of cosecant is going to be cotangent times cosecant x. And because cosecant starts with a c, we should put a negative sign up front. So negative cotangent cosecant. So those are our four derivative rules for today. Okay. So I'll just repeat them here on the next page here. To remember them, if it starts with a c, the derivative is negative. Tan and cotangent, the derivative is something squared. Secant and cosecant, the derivative is something times themselves. And how do you know what that something is? Well, tan and secant go together. Cotangent and cosecant go together. Okay, so let's practice those derivative rules. We'll do three little examples here. So again, just have those derivative rules down on a piece of paper beside you as you approach these examples. So our first one, y is equal to the cotangent of 2x squared minus 3. Well, first off, we know from our list of rules here that the derivative of cotangent is going to be negative cosecant squared of x. Okay? So how do we apply that rule here? Okay? So we've got a composite function, so we've got to use chain rule here. Our outer function is the cotangent. So the derivative of cotangent is negative cosecant squared. We want to keep that inner function the same. So the inner function is the 2x squared minus 3. So 2x squared minus 3. Now we want to multiply by the derivative of that inner function. So the inner function, again, 2x squared minus 3, its derivative is going to be 4x. So negative 4x cosecant squared 2x squared minus 3. All right. So here is where the fun begins. We have got secant of cosecant of x squared. So three functions here, nestled one inside each other. We're going to have to use chain rule twice. Now, the two trig functions we have are secant and cosecant. So let's just establish what are the derivatives of those things. Well, the derivative of secant x is going to be tan x secant x. And the derivative of cosecant is going to be negative cotangent x cosecant x. So what is our outermost function here? Got to move this down a little bit. Our outermost function is the secant. So that's the derivative that we're going to do first. Derivative of secant is tan x secant x. Now, we don't have secant x. We have secant of cosecant x squared. So in this rule over here, everywhere we see an x, we are going to put this inner function, cosecant x squared. So the first term is going to be tan cosecant x squared. Secant, starts with an S, secant cosecant x squared. Okay? So the derivative of our outer function secant has two terms in it. So we've got to have that inner function cosecant x squared subbed into each of those two terms. Chain rule. This gets multiplied by the derivative of that inner function. So what is our inner function? Cosecant x squared. Derivative of cosecant also has two terms. So into each of those two terms, we're going to sub the function that is subbed into cosecant, which is our x squared. So this is going to be negative cotangent x squared cosecant x squared. Finally, after all of that, we've made it to the very innermost function, which is our x squared. Derivative of x squared is 2x. So that's our derivative. Tan of cosecant x squared times secant of cosecant x squared times negative cotangent x squared times cosecant x squared times 2x. Okay? Easy as pie, right? And we'll be getting to pi when we start doing angles and radians. All right, our final derivative here of the day. 1 plus tan x divided by secant x. We've got two trig functions, and we're going to have to use the quotient rule. So first, let's jot down what our trig derivatives are. Derivative of tan x is secant squared of x. The derivative of secant x is tan x secant x. Whoops, and I forgot my x there. Sorry. All right, let's apply our quotient rule. We want derivative of the numerator, which is 1 plus tan x. Well, the derivative of the 1 is 0. Derivative of tan x is secant squared x. Multiply by the denominator, which is secant x. We're going to subtract our numerator, 1 plus tan x, and multiply that by the derivative of the denominator, which is secant squared. Oh, no, sorry. Derivative of the denominator secant. Derivative of secant is tan x secant x. All of this gets divided by secant squared x, our denominator squared. And now, let's see, can we simplify this thing at all? Well, let's look and see if we can factor. We've got two terms in the numerator. There is a secant x that is common to both of them. So we should factor out that secant x. So I'm going to pull out a secant x. First term, I'll be left with secant squared x. The second term, I will be left with the 1 plus tan x times the tan x. On the bottom, still have secant squared x. Now, one of these secants on the bottom is going to cancel with that secant that we're able to factor out. So what is this going to be? Well, if we were to, and we can probably just leave it like this. Secant squared x minus tan x times 1 plus tan x all over secant x. Okay. There is some more simplification that you could do here, but you couldn't do that simplification without applying a trig identity. So we're not going to go any further. So once you get it to this point, unless you really need to simplify it in order to solve it, so if you're finding a tangent, where a tangent is horizontal, you're setting this equal to 0 and solving it. Unless you have to do something like that, this is where you're going to stop.